All right, so the new unit. So our goal today is I can understand what a periodic function is and can determine its key features. And also I can graph y equals sine x and y equals cos x. So these are related to our previous unit on trigonometry. So periodic functions. Now, for those of you that have taken physics or are taking physics, there's a lot of overlap between what you're doing there and this unit. So first of all, a periodic function is a function that repeats in a regular way. And what we mean by a regular way, it's almost like it's a stencil that you pick up and you move. You pick up and move. So that's why we're talking about it being repeats in a regular way. So some people like to think of it as a stencil. Okay, and I'll use that analogy a little bit later on as well. And the reason we study periodic functions is it models a lot of real life situations. Okay, whether you're going to see them or not, it will depend on what you're going to do with your life after high school. So some of these real life situations include weather patterns because it repeats. Typically, for instance, in this area, we end up having spring roughly this around the same time of the year, the same with summer, fall, and winter, and also our temperatures are roughly the same in those periods. So in a sense, that we're repeating it in a regular way. Tidal waves is another example. High tide, low tide, high tide, low tide. Sound waves, okay, really a comparison with physics as well. Population cycles, especially population of animal cycles, especially if humans aren't intervening. Electrical current is another one as well. And there's other ones. Okay, so first of all, let's take a look at some periodic functions. The reason that we consider them periodic, remember they repeat in a specific way. So if I look at this, you saw me highlight it in green. So now if I take it, that's my stencil and it repeats itself. And one would assume that it would keep on repeating and repeating and repeating. The same thing is true with this one here in the sense that it's a different pattern, different stencil, but again, very much the same kind of process in the sense that there's my stencil and it repeats itself. Okay, and another one, a little more jaggedy one, but again, the same process that it repeats itself in a regular way, in the sense that where its highs are and its lows are happen regularly, same time frame. The height between the high point and the low point doesn't change. It's the same throughout the stencil. Now, for those of you that maybe have taken construction, you've maybe seen Galloping Gertie. And if you try Googling Galloping Gertie, you'll see it's a suspension bridge and you can see how it oscillates. Okay, so you can always try that as well in your free time, which I know you have lots of. So let's talk a little bit about terminology. So first of all, if we talk about the two really big things are period, sometimes called cycle, especially if you're in physics. And what it is, it's the measure of the horizontal length required before the pattern repeats. Okay, so if I look here, if I start as this being my starting point, it repeats again at this location. So this here then becomes this length that becomes the period. Okay, so it's the length, and that would be the period. Okay, and obviously your axes would have numbers on it, and you could actually read how long the length is. Amplitude, on the other hand, is half the vertical measure of the graph. Okay, so when we talk about half the vertical measure, we can look at a high point and the low point of the graph, and it's half this distance. So amplitude is half that distance. It's also considered the distance from the middle of the graph and the maximum height. Okay, so if we look at it just being this part here, that would be the amplitude. So we only want half of the vertical height of a graph. Now we're only interested in what we call its absolute value. So I don't care if it's positive or negative. I'm only after the number. Okay, now in physics you talk about crests and troughs. So obviously the distance between the crest and the trough, so half that distance, is what we call amplitude also in physics. Now, what we're going to be looking at is sine and cosine graphs. Okay, and what's special about them is as that angle of rotation around that unit circle, we go around, x increases. Okay, and x is actually, in this case, it's not as x is cos and y is sine because we're talking about slightly different because we're graphing. So the x in this case is theta. So as the angle increases, x, change in a regular and periodic manner. So we know that because of coterminal angles, as we go around, they have the same values. They have the same values. They have the same values. So that's where we get a regular and periodic manner. So when we graph, we transfer the values of y equals sine x and y equals cos x to a horizontal axis where the x-axis is measured in, for us it's going to be measured in degrees. Next year for you it's going to be measured in radians. Okay, and the y-axis are the values of the trig ratio at the various values of x. Okay, so we're putting angles along the x-axis and the trig ratio for the y. So let's actually look to see what this looks like. Okay, so what we're going to do is, now I left the link here for you so that if you want to go and play with it again yourself, you can do that. And it's up here so you can see it. And so what I'm going to do is I'm going to go to this link and we're going to watch this unit circle in action. What we're going to be looking at is the green line, which is the angles, as well as the blue. Okay, so we're going to be looking at blue and green. Okay, so just hold on a second while I bring that up. So here is that applet I was talking about, and I've clicked off sine x because that's the one we want to look at. I'll also look at these other two. We're only responsible in this course for sine x and cos x. However, next year you'll be looking at tan, and so we will look at the relationship there as well. So what's going to happen is I'll play it a couple times. So I'm going to start. And so what's happening along this green here has to do with as I'm going around the circle. You can see the green, as you can see, I'm increasing my angle until I get up to 90 degrees. And then what happens, this is here would be 90. And then I keep going around in the green. I'm getting a larger and larger number until I get to 180 here. And then notice what happens. It keeps on going. The next spot would be 270 and again at 360. So it keeps on going. And as we're rotating around the unit circle. So what's happening is it's the angle, it's the green as it increases, and then something else is happening. Now I'm going to suspend it for a second. It's not finished graphing it. I'm going to reset it. So this time what's going to happen is we're looking at the blue. The blue is sine because sine is the value of y. It's the value of y and the trig ratio. Okay, and you can see that it reaches its maximum point at, you should know this, at 1, and then it gets smaller and smaller until I get to, sorry about that, until I get to 180 degrees, and we know that the value of the trig ratio at 180 for sine is 0. And then we know from CAST, C-A-S-T, that the ratio then becomes negative, y's, and that's what's happening here. It's graphing below the x-axis because those trig ratios are negative until I get back up to 0, which is 360. We know that sine equals 0 there. So what happens is we know we could keep on going around and around that unit circle, and it would keep repeating this pattern over and over and over again. So that is really what's happening. We're unwinding that unit circle and transferring, in this case, the y values, which was blue as it was going around. Okay, as I said, you can experiment with this yourself too by going to that website and play with it so you have a little better understanding of it as well. Okay, so now what we're going to do is we're going to actually graph it ourselves. So what we're doing is we're choosing our values for x. Now remember, x is the values of theta. Okay, so it's actually in degrees. So for instance, if I choose 0 degrees, in order to calculate my y value, that would be sine of 0. Now you know sine of 0, if you take your calculator, it tells you that it is also 0. And if we actually take values that we do know, so sine of 45 degrees is that 1 over square root 2, or square root 2 over 2, which is approximately 0.707 da da da. So at 45 degrees, we're approximately here. At 90 degrees, remember, when it's 90, sine of 90 degrees is 1, positive 1. And so, if you notice, I skipped some there. There we go. So is that 1? And then what happens is we've reached the top of the unit circle, and now we can come back down. So if I add another 45, we know that we're at 135 degrees. 135 degrees is also 0.7. Which is approximately there. Now this isn't a straight, it is an actual curve if we actually did some more points in between, because you know that, for instance, sine of 30 is a half, which is approximately in here. Okay, so what we keep on doing is at 180, we know we're back down to 0 again. And now I'm just going to, because I know I'm going to go into the negative zone, so if I choose this time 270 degrees, sine of 270 is negative 1. And when I get back again at 360, I'm back at 0 degrees. Now, as I said, we could keep on going and going and going. So at 450, if you took the sine of 450 degrees on your calculator, you would find that you were at 1 again. So what's happened here is we've actually, you can see that it's actually repeating itself. And so now what we do is we draw a smooth curve as best we can. Mine's not real smooth. That part there is too ugly. It's going to have to disappear. And here we go again. Now, there's nothing that says that I can't go into the negative angle zone either, because we know if we rotate around the unit circle the other way, that we would end up also creating trig values. So it actually would go down to here too if we wanted to. Okay, now the graph continues and continues. However, when you're putting your arrows, make sure that you don't have your arrow pointing up here, because it doesn't go up there. Okay, it only fits between, you can see, -1 and +1. So what I'm going to do is now we're going to look at the properties of y equals sine theta, and then we'll quickly look at cos x for the next part of the video.